This is where we got to last time with Snell's law. We found that n1 sine theta 1 equals n2 sine theta 2. I've uploaded on here some places where you can go to explore this further. There's Walter Fent's refraction applet, which allows you to adjust theta 1 and theta 2 and see what happens. And there's also Mr. Douglas talking about what happens when light passes through various different shapes. But we're not looking at that. We're trying to get a handle on how Snell's law works. And the first thing we need really is some values of refractive index. And here they are. Ooh, that's quite big. Okay, let's see if we can just make it a little bit more manageable in size. Okay, so we've got medium and refractive index. Haha, the medium does not mean medium as in average or as opposed to large or small. It's the medium of the glass or whatever the light is going into. And then the refractive index. There's no unit mentioned. That's because the refractive index is simply a number. It's a ratio. And the one thing that hasn't been included in here is air. So I'm just going to add it at the bottom. The refractive index of air is 1.0. It's a tiny bit bigger than 1.0. Is it 1.00001 or something? And it actually varies a tiny little bit according to temperature. But we're going to assume that the refractive index of air is simply 1. So reminding ourselves then what we want to do is consider light going into glass with the normal, and we've got our light coming down, and I just wanted to get into red again because I like red. Way up here, there's theta 1. What can you tell me about theta 1 and theta 2? Qualitatively, which one's bigger? Well, we haven't mentioned the mediums yet. This one's air, and this one's glass. Okay, so suppose theta 2 was 30 degrees. Then we now know that we can write out Snell's law, n1 sine theta 1 equals n2 sine theta 2. We know n1 is 1. We know n2, which is glass, just ordinary glass, so that's more like 1.5. You can write 1.52 if you like, but ordinary glass has a refractive index of 1.5. And we know theta 2. Theta 2 is 30 degrees. Okay, so let's go into a nice new color, something like green. N1 is only 1, so we don't need to write that down. Sine theta 1 equals N2 is 1.5. Sine theta 2 is sine 30. Okay, I want you to get your calculator out, pause the video, and calculate the value of sine theta 1. This is not the value of theta 1. This is the value of sine theta 1. So to find theta from that, we have to use the inverse sine function. If you don't know how to use the inverse sine function on your calculator, then Google it. It'll show you how to do it. We then need to take the inverse sine to find the angle theta. Now, having found this angle theta 1, press the sine function and check that you go back to the value of sine theta 1. And then press the inverse sine function and check you go back to the value of theta 1. And finally, check, should theta 1 be bigger or smaller than theta 2? Is it? That's all we've got time for this time.